Hello and welcome to Binpipe. I'm Prasanjit. Today we'll discuss about DevOps for ML and AI with Kubeflow. Now, this is a vast topic actually, but I'll begin by discussing what artificial intelligence is, what machine learning is, what are the differentiators, and then we'll discuss how DevOps comes into play uh, in these disciplines. Like artificial intelligence, machine learning are a discipline of computer science on its own, but DevOps practices help uh, artificial intelligence and machine learning as well as they do for any other cloud native services. So how do they do that? What is MLOps? So new terminologies come into play when we discuss the amalgamation of machine learning and artificial intelligence. So MLOps is one of them. So we'll discuss that, and we'll also discuss what Kubeflow is. It is actually a tool related to these disciplines. So we'll discuss what that is and when is that used and all that. So this will be a discussion about AI, ML, Kubeflow, MLOps, and all that. So let's begin by discussing what artificial intelligence is. Unfortunately, there is still much confusion within the public and the media regarding what genuinely is artificial intelligence and what exactly is machine learning. Often these terms are being used as synonyms. In other cases, these are being used as discrete parallel advancements, while others are taking advantage of the trend to create hype and excitement as to increase sales and revenue. But as science students, as practitioners of DevOps, machine learning, AI, we should not be doing that. We should clear the air. So that is one of the motives of creating this video. And then we'll take this on to how we can apply DevOps into ML and AI, and how we can use tools like Kubeflow to do that. So this is just a getting started video. We are not going into depth. All things remain at a high level. And in forthcoming videos, based on your interest and your comments to this video, I'll create more content around this. Like you would be interested how to install Kubeflow, how to get that applied or implemented with your machine learning data sets, or how to get that implemented for other AI avenues. So what is machine learning? Quoting interim dean from the School of Computer Science at CMU, he says, a scientific field is best defined by the central question it studies. The field of machine learning seeks to answer the question, how can we build computer systems that automatically improve with experience, and what are the fundamental laws that govern all learning processes? So machine learning is a branch of artificial intelligence that, as defined by Tom Mitchell, is the study of computer algorithms that allow computer systems to automatically improve through experience. So ML is one of the best ways. You can say it's one of the most used ways that we expect to achieve AI, or artificial intelligence. Now, machine learning relies on working with small to large scale data sets by examining and comparing the data to find common patterns and explore nuances. For instance, if you provide a machine learning model with many songs that you enjoy, along with the corresponding audio statistics like instrumentality, tempo, genre, and all that, it ought to be able to automate depending on the supervised machine learning model used, and generate a recommender system so as to suggest you what music you would like. So it will also suggest you where that music exists and all that. So you do not have to look for your tastes. It'll understand your tastes of music and recommend you the music you like. So that is what machine learning actually is and what machine learning algorithm do. Now this kind of learning from an example data set is called supervised learning. Now there is another machine learning system called unsupervised learning, where you have which uses pattern detection or descriptive modeling. These algorithms do not have output categories or labels on the data, so the model trains with unlabeled data. So that is unsupervised. And there is another branch of machine learning, and that is called reinforcement learning. Now this is very popular as well, and reinforcement learning aims at using observations gathered from interaction with its environment to take actions that would maximize the reward or minimize the risk. So this is similar to how a baby learns. Like the baby would touch something hot and then understand that this is hot and not pleasant to touch, so it would not touch that same object again. Or the baby tastes something that is sweet and likes it, so it keeps on asking for that particular object and knows that this is something that is pleasant. So it is governed by experience and rewards. So if something is rewarding, that is to be done. If something is not rewarding, or there is a punishment involved, then that thing isn't to be followed in future. So that is called reinforcement learning. This is the basis of all auto-driven cars and all those sort of superhuman state and beating humans on computer games. All these things are designed around reinforcement learning. So that is about machine learning in a nutshell. Now, what are the other disciplines of AI? So machine learning, as I said, is just one wing of AI. There are a lot of other wings as well. One is the NLP, natural language processing, which involves on text generation, question answering, context extraction, classification, and machine translations. And there are other branches like expert systems, speech, where you can convert text to speech using AI. You can convert speech to text using AI. You can translate from between different languages. You can use AI vision systems for auto recognition, image recognition, video recognition, and all that. And nowadays, AI is also being used for planning as well as robotics. So, in total, AI is the science and engineering of making computers behave in ways that until recently we thought required human intelligence. So that is about AI. So let's not digress further into this, because we'll be taking all this separately in different videos based on your feedback. So let's move on to our next slide, where we are discussing what MLOps is. So machine learning ops is the method in which we can take care of our machine learning tasks and put them into a DevOps framework. Like for example, in DevOps, you have pipelines where you, as soon as the code is pushed into a repository, triggers a pipeline and a series of tasks from where the build is done and then tested and then deployed and then finally goes into production. So this entire series of continuous integration and deployment kicks on. Similarly, in machine learning, you can adopt a DevOps model of having a continuous deployment and continuous learning. So the machine learning models, so the training and the inference, all these steps can be made continuous. So normally what happens in a research environment, there is manual extraction of data from databases, then it is cleaned up, and there is in-memory analysis, there is some bit of small-scale training on that data, and there is a manual evaluation. But however, if we want to make it more refined and more effective, we can create a pipeline based on DevOps methodologies, like we do it for normal deployment, CI/CD deployment systems. So here you can put in ETL systems, you can stream the data, you can pull in data from different APIs, you can train with a large data set and many algorithms, and you can give real-time inferences. So we'll come to all that in a while with real-life examples as well. So how do we do that? There should be some tools to take care of that. Now, Kubeflow is one of those tools. Now, what is Kubeflow? Kubeflow enables you to take in the scattered data from the edge, ingest it, classify, transform it, analyze, train it, and then provide insights. So the entire machine learning workflow is covered using this tool called Kubeflow. We'll go more deep into Kubeflow and understand what it does in a while. Now, what is Kubeflow? It is basically an open source project integrating the most popular data science tools in one place. The main concept is to streamline and build machine learning applications from prototype to the production, as I said, entirely traversing the machine learning pipeline. So Kubeflow has Kubernetes under the hood. So it is an exciting toolkit to make data scientists and data engineers' life easy. So what are the components of Kubeflow out of the box? We can discuss that. One is the notebook. Like we have Jupyter notebooks, so Kubeflow comprises of Jupyter notebooks. So this is basically an all-in-one application. Once you install and run it, you can do it on a production system as well as on your laptop using mini Kubeflow. You can visit the Kubeflow website for more information, kubeflow.org. So you will get some information about what Kubeflow is and who maintains the project and so on. I'm giving you a brief overview so that you know what the beast is. So Kubeflow, as I said, is an all-in-one tool for your MLOps. So it comprises of notebooks. So you have a Jupyter Lab and Jupyter notebooks in there. Data scientists and ML enthusiasts would be familiar with this. Then it has model training systems inbuilt. You have TensorFlow, TensorBoard, and so on. So notebooks, as I said, are the industry standard for prototyping machine learning models. So in Kubeflow, you can quickly deploy Jupyter Lab instance and start creating your ML models. And Kubeflow has integrated multiple options for model training, from local training in Jupyter Notebook to APIs. It has APIs that can connect to Google Cloud and even connect to your SageMaker in AWS. And it has the TF job as well for TensorFlow framework, and TensorFlow model analysis systems are available to analyze your models and get graphical inferences like this. And it also has Kubeflow Fairy, which is a Python package that lets you train the machine learning model in a hybrid cloud environment. So just imagine, like using this tool, you can connect to multiple clouds together and train your model at a distributed cloud environment. So it can be in your local machine, it can be in some other cloud, it can be anywhere. So it also allows you to build a Docker container and deploy it to Kubeflow or AI platform for training. So that is Kubeflow fairing. Then you have options for hyperparameter tuning. Then there is a Kubeflow pipelines uh, module, which are a new approach, as I said, MLOps approach to build end-to-end machine learning workflow. Every step of the pipeline is a Docker container, and the pipeline is defined in a .yaml file. It means the entire thing is portable and scalable. So these pipelines can be deployed to Kubernetes clusters. It also cuts short the whole workflow and the model prototype to production path. So that is another thing. Then there is another module in Kubeflow called experiments, which offers easy way to compare different runs of the pipeline. That is, you can create a pipeline with a model training and then run it multiple times with different parameter values, and you'll get accuracy and ROC AUC scores for every run compared, plus a lot more of inferences out of this. And there is a model serving out of the box. There are multiple ML model serving options available: TensorFlow, Istio, TensorFlow Batch Predict, Seldon Serving, NVIDIA TensorRT Inference Server, and PyTorch Serving. So all these are included in this. And apart from that, it is cloud native. It can be easily deployed in AWS, GCP, or Azure. And you can even try out the project called MiniKF. You can search for it, MiniKF. And that is a mini version of Kubeflow that you can install in your laptops and try it out. And this is open source and free for you, so you can use it without a charge. So that is all about what MLOps is and what Kubeflow is and what DevOps, how DevOps comes in to help ML and AI. I know this was a bit very high level, not deep. So we can now move on slowly based on your feedback to each and every topic and understand how Kubeflow can be implemented and how each of these modules work. So hope I gave you a good understanding of what machine learning is, what AI is, how it is different, how they are different from each other, and what contains what, like AI contains machine learning. So we discussed that. We discussed how DevOps will help AI to make it more effective. And we discussed what Kubeflow is and what the tool stands for. How does it help in these disciplines? Stay tuned, keep watching my videos, keep learning, and comment on what you need out of me. I normally love to produce videos on DevOps, site reliability engineering, about Linux, about cloud, and I also like mathematics and computer science. So anything, just ask me in the comments. I'll try to create some videos, and I love teaching, so I'll be with you. See you around. Keep learning. Thank you.